We're going to keep looking at right triangles today, and we wanted you to be able to identify and apply right triangle trigonometry functions to any triangle. The first one on your note sheet says that the Americans with Disability Act, or the ADA, provides regulations designed to make public buildings accessible to all. Under this act, the slope of an entrance ramp designed for those with mobility disabilities must not exceed a ratio of 1 to 12. That means for every 12 units of horizontal run, the ramp can rise or fall no more than 1 unit. So they want us to find in this picture what would be the length of the ramp then. Well, we should be able to do this from what we learned on the last notes. If we had a right triangle here, and we know the two legs of that are 1 and 12, we can find the length of the ramp or the hypotenuse by doing Pythagorean Theorem. A squared plus b squared equals c squared. So here we'd have 1 squared plus 12 squared equals our missing side squared. Square these and add them up, and we get 145. And then we could approximate what that would be by taking the square root of 145. And if you do that on your calculator, you can see that the square root of 145 is approximately just a little bit more than 12. So maybe about 12.04 feet. Okay, so no problem, we know how to do those types of problems. But the next question wants us to figure out what is the measure of angle A? What's the angle that we should build that ramp at in order to achieve this? Well, that gets into something else that Pythagorean Theorem cannot find. And what we need is to go back and look at something you did in geometry, where when you have right triangles, you can find out other stuff when you know an angle in one of the sides by using the trigonometry functions sine, cosine, and tangent. So recall that when you're doing that, sine, cosine, and tangent, the three main trig functions, are abbreviated with the first three letters. So sine, S-I-N, cosine, C-O-S, and tangent, T-A-N. Okay, those buttons are all located on calculators, and we'll look at that in a little bit here. But we want to know, what do all of those sine, cosine, and tangents do again? Those three functions, we can use our saying SOHCAHTOA to figure them out. So sine function is always your O over your A, the opposite side over the hypotenuse. Cosine, C-A-H, is always adjacent over hypotenuse, and tangent's always opposite over adjacent. So when you're doing one of these triangles and you want to find those, you want to locate what's your opposite side of your, the side opposite your angle, the side adjacent to your angle, and the hypotenuse. If we use this one, and we're finding sine of angle A, here's angle A, that would mean that our opposite side is A here. Our hypotenuse is always the longest side. That means our adjacent means next to. The adjacent side is the one next to our angle. That would not be the hypotenuse right here. So on this one, the sine of angle A, if we were to write it out, would be the opposite side, which is little a, over the hypotenuse, which is C. The cosine on the cosine of angle A, which is adjacent, would be side B over the hypotenuse with side C. And the tangent would be the opposite side, which is A, over the adjacent side, which is B. Now, you looked at those last year in geometry. There's also three other trig functions, though, that you did not talk about, and they're the reciprocal functions. What is a reciprocal again? Remember, reciprocal is where you flip the fraction. So the three other ones, reciprocal functions here, are called cosecant, secant, and cotangent. And if you notice, they are the exact opposite, or not opposite, but reciprocals of the ones listed over there. Sine is opposite over hypotenuse. cosecant's hypotenuse over opposite. So it's just the reciprocal of these two flipped around from the one across from it. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So you just do the reciprocal to find those new ones. We want to be able to use this in order to find out some things in our problems here. So the SOHCAHTOA, or this number one problem on your note sheet, they want us to find the values of the 6 trig functions for angle theta. Theta is this variable right here. It's a Greek letter that they use for angles a lot. You can just treat it like it would be an x. It's just another variable. So here's that angle in the picture. We want to list out what is sine, cosine, tangent for these ones. Okay, so if that's our angle, okay, we want to list out all the other sides. Hypotenuse doesn't matter regardless of which angle we're looking at. It's always the longest side. This side's going to be our hypotenuse. Our opposite side is the side opposite our angle. So opposite side in this one would be the one that's a length of 4. Adjacent means next to, so the one next to our angle that's not the hypotenuse would be the 3. So that's our opposite adjacent hypotenuse in this problem. So sine of angle theta, sine uses opposite over hypotenuse. So here that would be an answer of 4 over 5. Cosine, adjacent over hypotenuse. In this problem, that would be 3 over 5. Tangent is opposite over adjacent. So our opposite here is 4. Our adjacent is 3. The reciprocal functions are the next 3. Once you have those, you can just do the reciprocal of the ones we had before. Now, the cotangent and tangent ones are easy to remember because they sound the same, cotangent, tangent. You should easily be able to pair those up. So if we do the reciprocal of 4 over 3, it would be 3 over 4. The other two are a little more confusing. You would think that sine and secant would go together because they both start with S, but they actually don't. Cosecant is the reciprocal of sine. So it's kind of the opposite letter. So the reciprocal of these two would be 5/4. And secant and cosine go together. Reciprocal of that one would be 5 over 3. So those would be the values for those reciprocal functions. All right. Going on here, the next one wants us to find out if cosine of some angle is 2 over 5, what would the value of the tangent of that same angle be? All right, so to solve that, we want to do kind of like we did in the last problem and get ourselves a little picture here. So draw out or just sketch out a right triangle. We need angle A on here, so somewhere list an angle A. Can't be the right angle, it has to be one of the other two angles. And then we want to put on these two numbers, the 2 and the 5 somewhere. Now we don't just want to randomly put them, we want to put them where they're supposed to go in the problem. Well, if we want to place them in the right place, we should look at cosine. What do we know about cosine C? Cosine's always going to be adjacent side over hypotenuse. Let's find where those would be on our little picture here. Hypotenuse is the longest side. Opposite our angle is going to be opposite. Adjacent or next to our angle is going to be there. So cosine, again, is A over H. That's telling us here this is A, this is H. So now we want to put those two numbers in the right spot on our picture. The adjacent side should be 2. The hypotenuse should be 5. Okay, so now they want us to find what is tangent of the same angle A here. Well, we know tangent is opposite over adjacent. Okay, so in our problem, our answer should be a fraction, kind of like it was here, but with the correct numbers for tangent. Well, we know the adjacent side that we need here. The adjacent side on our picture is 2, so the bottom of this is going to be 2. The only question is, what is the opposite side going to be? We don't know right now what that is. If we knew that, we could finish this problem. Well, there is a way to get it. You did it a whole bunch in the last video or notes, and that is if you know two sides of a triangle, 2 and 5 here, we can find the third side using our good old friend Pythagorean Theorem. So set up a Pythagorean Theorem problem to find it out. 2 squared plus whatever this missing side is here squared equals our hypotenuse squared. And we can solve this out really quickly doing Pythagorean Theorem. Subtract 4 from 25, we get 21. Take the square root of 21. 21 is not a perfect square, and there's no perfect squares inside of that. So in this case, what we're going to do is just leave that as square root of 21. It's going to come out to be probably something around 4 point something, but rather than write that out as 4 point something, we're just going to leave it as square root of 21. So the exact value of tangent of angle A in this problem would be the square root of 21 over 2. All right, let's try one more of those. Number 3 here. They want us to do a different one, kind of the same type of problem, and find sine of side B. Why don't you pause the video and see if you can attempt this one on your own. All right, let's see what you got. If you drew out a little picture, and hopefully you did, put angle B on there somewhere. Label the sides. This would be our opposite side, adjacent side, hypotenuse. This one's dealing with tangent. Tangent's opposite over adjacent. That means our opposite is 3, our adjacent is 7. So this side would be 3. This side has a length of 7. Now our picture it's not very accurate. That's fine. We're just using our picture to help us out a little bit. We want to find what's this hypotenuse, what's the missing side. Do some Pythagorean Theorem and you can find that out. So you got 9 plus 49 would be 58. And so it looks like x is square root of 58. So our missing side here is the square root of 58. Now we should be able to answer our question. What is the sine of that same angle B? Sine is opposite over hypotenuse. So our answer is going to be the opposite side, which is 3 over the hypotenuse, which we just found, square root of 58. And that would be the solution to this problem. Okay, continuing on here. We also can use then sine, cosine, tangent to find missing sides and missing angles if we know some information. So on number 4, they want us to figure out what's the missing side x here. We can't use Pythagorean Theorem because we only have one side length value. If we knew another one, we could use Pythagorean Theorem. So what we're going to have to do here is some trigonometry. Use sine, cosine, or tangent to do this. Again, especially early on here, label the sides. Our hypotenuse is the longest side. Opposite sides here, adjacent sides here. Now, if you look at what we're given, I don't think we're really going to be interested in using this adjacent side. We don't know anything about it. We do know the length for the hypotenuse, and we're interested in finding the opposite side. So what you want to do is see, okay, which of our 3 trig functions uses O and H? Well, if you go to our SOHCAHTOA saying, you can see O and H go with sine. This is going to end up being a sine problem. So write down the trig function that you want. Right after the trig function always comes the angle. So our angle in this problem is 20 degrees. Equals, and now just like we've been doing, we want to set up the fraction that it equals, or the ratio. So the ratio for sine is always opposite over hypotenuse. Our opposite side in this problem is x. Our hypotenuse in this one is 15. If we solve this equation, we can now find our answer. Well, our goal in solving is to get the variable by itself. Here our x is being divided by 15. We can undo that by multiplying both sides by 15. Okay, so here our x's cancel, and our answer is going to be whatever 15 times the sine of 20 degrees is. So now this is where you use some technology to figure out what that's going to be. Now, when you're doing this, make sure your calculator is in degree mode. So if you hit your mode button, which is usually on the top, you get some options here. And right now, if you move down to the third one on this calculator, you can see there's 2 options, radians, degrees. Radians, if you go on to trigonometry class next year, you'll find out about what that is. We want to be in degrees though, so select and make sure degrees is highlighted Otherwise, you're going to get some funky answers that are in radians. So now type in the problem, 15 times the cosine, and then type in, or sorry, sine, type in your degrees here, which is 20, hit enter, and it'll tell you. Looks like it's about, our missing side length is about 5.13. And so that would be the answer to the problem. Okay, number 5, they want us to do something similar here, but they want us to find or solve the whole triangle, meaning they want us to find all the missing stuff. What's all the missing angles? What's all the missing sides? Okay, let's start with side x here, just like we did on the last one. You could start with z, it wouldn't matter. Let's do x since that's the one we did last time. Again, label the sides. What are all the sides going to be? Well, if this 35-degree angle is the one we're using, that makes x our opposite side because it's opposite the angle. 10 would be our adjacent side because it's next to our angle and it's not the hypotenuse. Hypotenuse is always the longest one across from the right angle. So if we're going to find x here, it appears we're using opposite and adjacent. So opposite and adjacent, that's our good old friend tangent. That's the one we want to use in this problem. So write down tangent. The angle always comes to x, so 35 degrees equals, and it's always opposite over adjacent for tangent. That would be x over 10. So now we want to solve that. Our variable is being divided by 10. Do the opposite and times by 10. These cancel out. So on our calculator, what we want to do is 10 times the tangent of 35 degrees. 10 times the tangent, 35. We get really close to 7. So x is almost just about 7 here. Okay, so we found that missing side. Now we want to find out how long is side z going to be. This side's pretty close to 7. Well, to find out z, we could do one of two things now. We know from our last notes, if we know two sides, 7 and 10 here, you can always do Pythagorean Theorem to find z. So one way we could find z would be doing 7 squared plus 10 squared equals z squared, and we could find it that way. It'll work. 7 squared is 49, 10 squared is 100. Add those up, you get 149. We could take the square root of 149 and get that. Let's do that quick. You did square root of 149. It's about 12.2. So z in this problem is pretty close to 12.2. Okay, now that's one way to do it. Nothing wrong with that way. Works great. I'm going to show you, though, that you can get that another way. You could also use trigonometry again. Trigonometry, if we set that up, should give us the same exact solution. So if we were going to set that up with a trig problem, trig on this one, we would want to be doing, we can use our side of 10 again, and then our missing side of z. That would be a and h, the adjacent side and hypotenuse. A and h go with cosine. So we could get the same thing by setting up a cosine problem. Cosine, 35 degrees, equals adjacent, which is 10, over our hypotenuse, which is z. If we solve that out, that should give us 12.2 as well. Now, the reason I want to do this one is this one solves a little bit different than our last problem. On our last problem, our next step was to multiply by 10. Is that going to be helpful in this problem? No, because here, the 10 here would not cancel out with our 10 here because both 10s are on top. So in this case, rather than multiplying by 10, which doesn't cancel anything out, we want to multiply by whatever's on the bottom. And in this case, what's on the bottom is z. So we need to multiply first here by z. That would cancel out the z's on this side. Here's the thing, though. We haven't finished solving this here because we still have something on the side with our variable. So this is actually a two-step problem now. Now we need to divide by cosine 35. So sometimes you might just times, sometimes you might have to multiply and then divide to solve these. So now we got z all by itself. If we type in 10 divided by cosine 35 on our calculator, it should give us that same answer of 12.2. Just to show you it does, and that this trig stuff works, let's type that in. Exact same, pretty close to the exact same answer that we got for square root of 149. So it does, this trig stuff does work out when you're doing this. So the answer for here would be the same thing of 12.2. Okay, last thing though, they did want us to find all the sides and all the angles. Well, we found all the sides now. It was 10, 7, and about 12.2. We got this one angle of 35. Angle Z is really easy to find. That's a right angle. That's 90 degrees. The only thing is, what's the last angle there? What is angle Y? Well, to find that, we got to go back to what you guys did last year in geometry. And last year in geometry, you found out what all the angles in a triangle always add up to. They always add up to 180. So if all the angles add up to 180 degrees, and we know one of them's a right angle, subtract that. We know this other one was 35, subtract that. Whatever's left should be our missing angle. So if you subtract those, you would find out that the last missing angle here would be 55 degrees. 55 would be our missing angle. So now we found all the sides, all the angles. All right, problem 6. Okay, number 6, this one we want to find something too. This time though, we want to find a missing angle. If you need to find a missing angle, you start the exact same way we started all the other ones. It just finishes a little bit different. So in this problem, our longest side is right here. That's the hypotenuse. The side opposite would be over here. The side adjacent to our angle would be right here. It looks like we're not really interested in the opposite side here. It's A and H. Well, from our SOHCAHTOA saying, that means cosine is the one we want to use. Always we put the angle after. Now here we don't know the angle, but that's fine, equals adjacent side, which is 16, over hypotenuse, which is 25. Now we want to solve that. Well, if we try just timesing by 25, that's not getting our x by itself or anything. We're actually got all our numbers over here. The problem is this side. Here's the side with our variable. How do we get rid of the cosine? Well, cosine's not something we can divide by. Cosine's a function, so we got to do the inverse function of that. And the inverse function of cosine is to make it what's called an inverse cosine. So to move this to the other side, it becomes cosine inverse, which in math they write as cosine with a little -1 there. It is on your calculator, and it's always usually located right by the cosine button itself. So on this calculator, it's right above cosine. So to select it, since it's in blue, we hit the second button, cosine, and it shows up as that cosine -1. Then you type in 16 divided by 25, the ratio, hit enter, and it'll approximate what that angle is. Looks like the angle, missing angle here is about 50.2 degrees. Okay, so that would be the missing angle. We started this notes off with a problem that asks about a missing angle. So let's go back to that one now and finish that. They want us to find what's the angle of this ramp. That's how we do it, how we just did. On this one, we have the opposite side and the adjacent side of this. So opposite and adjacent, that's tangent of our missing angle that we're not sure of. Here they're calling it A, so I'm going to call it A, I guess, instead of X, equals opposite, tangent's always opposite over adjacent, so 1 over 12. So to solve this, we want to move that tangent to the other side. It's going to become tangent inverse of 1 over 12. And so in your calculator, if you type in tangent inverse, So select the inverse tangent one of 1 divided by 12. It'll tell us about what that angle should be. Looks like it's not a very big angle, about 4.76 degrees should be the angle that we make that ramp at in order to achieve this Americans with Disability Act regulation. All right, there's one more of these. Why don't you pause the video, try it out, see if you can solve for the angle in number 7. All right, let's see how you did. This one has opposite and hypotenuse sides, which is sine. We don't know the angle, and sine's always opposite over hypotenuse. We want to do inverse sine on this one to find our answer. So type in inverse sine of 10 over 12, and you should have gotten, if you did it right, about 56.4 degrees for our missing angle. All right, in the ECT and other tests, a lot of times you're going to see these trigonometry type problems show up. So you got to be able to apply a trig problem to that. This one says, in order to construct a bridge, the width of a river must be determined. Suppose there's a stake planted on one side of the river, that's right here. There's another stake planted directly opposite at a distance of 50 meters to the left of the stake. So if we move over 50 meters here, and we measure the angle, and there's equipment that can measure angles like this that surveyors use. They figure out that that angle is 82 degrees. We can now figure out what this width is across the river by doing some trigonometry. So looking at our right triangle, looks like we got the opposite side and the adjacent side. Okay, so opposite and adjacent, that's tangent. So tangent of our 82 degrees equals always O over 8. So W, the width of the river, over 50. We can solve this one. Looks like this one we can solve by multiplying both sides by 50 and then using our calculator here to solve. So the width is going to be 50 times the tangent of 82 degrees. And it looks like it's about 355.8. And this one is measured in meters for our answer. So that would be how far it is across the river. Now we know how big we need to build a bridge or something like that. All right, last one here. John found that 2 trees directly across from each other in a canyon. When he moved 100 feet from the tree on his side parallel to the edge of the canyon, the angle formed by the tree on his side, John, and the tree on the other side was 70 degrees. Find the distance across the canyon. See if you can set up a problem to solve this out. It might be good to draw a little picture and see what you get. All right, here would be a little picture that could help you. You got your 2 trees. He walked parallel on this side of the canyon, so there's where John is. There's the angle. He walked 100. How far is it across the canyon from one tree to the other? Looks like, again, we have one that has opposite and adjacent. That's a tangent problem. So tangent of 70 degrees equals what over 100? If we multiply both sides by 100 and solve, you get the answer. And if you did it right, it should have come out to be about 274.7 feet across the canyon. All right, try some of these trig problems out on your